Good morning, guys. Today we're going to do actually our last set of notes before the review. Um, so this is 3.07, and so this is kind of the summary of everything that we've pretty much seen so far. And one thing I want you to take away from everything that we've learned is kind of having these steps in your mind. Um, One of the things that I had mentioned before is you can actually combine these first two together. Like you can do like a combination of a dilation and a reflection when you're solving for it. And then we have um, vertical translation, which I've usually been using purple, and horizontal translation. But these are all, the transformations that we've seen. And so in these 5 examples, we're going to kind of summarize everything. So the examples, if I move the page up this way, we have the following examples. Oh, actually it's 6 examples. Sorry. So to zoom out. So yeah, it's actually 6 examples. And so we're going to be looking at these 6. So let's go ahead and jump over to example 1. Okay. What we have here is, let's first figure out what type do we have, right? We have a cube root. The values for a cube root: -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Okay, and so the parent function here, and 1, 2, 3, 4, 5, 6, 7, 8 here. How many of you are getting better at drawing these curves? I hope you are. Right, we have been practicing them for so long. So let's look at the transformations that are going on. We have a negative inside, so that means reflect on the y-axis. And then we have a +1, which means we're going to move vertically up. All right, so let's do that. Let's reflect. So that means if we're reflecting on the y, that means the y-axis is going to be like our mirror. So anything that's on the right is going to go to the left, and anything that's on the left is going to go to the right. So do something like this, and then we're going to move all these points, all these pink points, up 1. So I'm just going to do that in purple. And so our final transformation are all these red points. So we'll graph. Awesome. Let's go over to example 2. Okay, so the type that we have here, it's squared, or it's to the power of 2. So we have quadratic. The points are 0, 0, 1, 1, and 2, 4. I actually like how that curve came out. Okay, let's see what's going on here. We have a negative outside. We have a negative outside, but negative always means reflect. And since it's outside, it's going to reflect on the x-axis. And then, let me change the color here. We have a -4 inside, subtraction of 4 inside. So that means, we have horizontal movement, and -4, is, instead of going to the left, because usually if you're on the x-axis, right, if you say -4, you go to the left. But remember, for horizontal, we do opposite. So even though it says -4, we're going to go to the right 4. So we're going to do horizontal movement to the right. Okay, so let's do the reflection. And since it's on the x-axis, the x-axis is now my mirror. So that means that every point that was on top will now be on the bottom. So that's moving these points over here. 2, 3, 4, 2, 2, 0. All right, and then the transformation, the horizontal transformation to the right. So every point's going to move to the right 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Awesome. Let's go to example 3. Example 3 is an absolute value. So that's -1, 1, 0, 0, 1, 1. And remembering that the absolute value has this V shape, right? Oh. Undo. I'm going to try and make it symmetrical. There we go. That's good. All right. Now let's see what's happening to this. It has a 1/2 inside. So inside there's a horizontal. I'm going to put H for horizontal. Horizontal expansion. And then the -10 is outside of the absolute value. So that's vertical. And since it's since it's minus, we're going to go down 10 units. Okay, so if you remember, for horizontal expansion, what we end up doing is multiplying all the x values times the opposite, the opposite of dividing by 2, multiplying by 2. So we're going to multiply all these x values times 2. So -1 times 2 is -2. 0 times 2 is 0, and 2 times 1 is 2. So that's going to give us new coordinates. So we're going to do negative 2, 1, 0, 0, and 2, 1. Again, I'm just following these new points. So my new x is negative 2, so I'm going to go to the left 2, but my y's stay the same. Okay. And then I'm going to move these red points down 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing with these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And over here as well. Okay, so I'm going to connect them. All right. See if I can get this. It's going to make myself a little pathway. Okay, that one, and then this. Rotate my iPad. All right, there we go. And just to kind of keep consistency, let me move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just so that I can have, purple paths here too. All right, let's go over to example 4. Okay, so let's figure out what type do we have here. It's a square root. Notice that the 3 is not the small 3 in front of the square root. So it's not a cube root. The 3 is multiplying. So just remember that. So the values for the square root are 0, 0, 1, 1. Square root of 4 is 2. Square root of 9 is 3. So it's 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, and 3. Okay. So let's see what's happening here. Looks like we have two things happening, and I'm trying to decide what color to use. 'Cause I know for the plus 3, right, it's going to be vertical and up, but there's a negative inside the square root and a 3 outside. Okay. What color do I want to use? I'm just going to use, I'll still use pink, but I want to use a different color. I don't know what color to use. Okay, I'll use pink and orange. Pink and orange. Okay, so this orange, since it's inside, it's reflecting on the y-axis. So that just means that's going to be my mirror, right? And then the pink, the 3 that I circled in pink, it means that there's a vertical, since it's outside, it's a vertical, so I'm going to put V, expansion. So vertical expansion means, or vertical dilation, vertical expansion. Vertical is going to affect only the y's, so all the y's are going to be multiplied by 3. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. Okay, so let's do the expansion first, and then the reflection. So we're going to do expansion first, then the reflection, then the vertical translation. Okay, so if I do the expansion, I'm going to put the point 0, 0 in pink. My next point is 1, because remember the x's stay the same, so 1, 3, that's to the right 1 and up 3. And then 4, 6, to the right 4 and up 6. Up here. And then 9, 9, 9. So to the right 9 and then up 3, 6, 9. Let me just check if it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's it. So these pink points are an expansion, so vertical expansion, meaning that these points expanded or stretched out vertically. They went higher than they were before. How much higher? Well, 3 times higher, right? 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So they stretched out 3 times as far. Then we're going to reflect. So if we're going to reflect on the y-axis, that means all the pink points that were on the right are going to be on the left now. Here. This one's going to stay there. And then here we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't know if you can see this one here, this point. I counted 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units this way because this is 9 units this way. Okay? And then we're going to move all these purple points up 3 units. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So my new distances are going to be these red points. Right? So let me connect these red points. All right. So again, just to summarize this one, because this one was a little bit different than we've seen before. So to summarize, what we saw is it did expansion first, multiply all the y values times 3, giving me new y values, but the x values stay the same. Then I was able to plot these pink points. Then I reflected over the y-axis. That means all the pink points that were on the right were now relocated to the left, like a mirror image. And then all these reflections, all the orange points, were moved 3 units up, giving me my final transformation, which is the red graph. Okay, let's go to example 5. What type of function is this one? It's to the power of 3. So if it's the power of 3, we call that a cubic. And the points for a cubic are -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, nope, didn't like the way that came out. Okay. So now, let's look at the transformations that are happening. There is a negative 1/4. So this is a combination. The negative is a reflection on the x-axis. But it's also in combination with a vertical compression. Vertical compression of 1/4. So I'm going to combine those two, and I'm going to combine them by multiplying all the y values times negative 1/4. Negative 1/4, negative 1/4, multiplying all these times negative 1/4. So negative 8 times negative 1/4. What's 8 divided by 4? That's 2, but a negative times a negative is positive. And this is going to be negative times a negative is positive. 1 times 1/4 is 1/4, which is 0.25. Then anything times 0 is 0. This is going to be negative 0.25. This is going to be negative 2. Okay, so if I plot these points, remember the x's don't change in a vertical dilation. Only the y's change. So if I plot these points in pink, that's going to give me negative 2, 2. Sorry. It's going to give me negative 2, 2. That's right here. Right here. Negative 2, 2. Negative 1, and then 0.25. 0, 0. Stay the same. 1 and negative 0.25. So the point is, this is kind of going a quarter of the way and a quarter of the way. And then the last point is 2, negative 2. That means 2 to the right and 2 down. Something like this. Okay. And then we should also see that there is, in the equation, there's a minus 6, which means that there's horizontal. Minus means to the right. And then there's a minus 2, which is a vertical transformation or translation going down 2. So we're going to do to the right, to the right 6. 1, 2, 3, 4, 5, 6, and down 2. And so to the right 6, 1, 2, 3, 4, 5, 6, and down 2. So this is my transformation. Awesome. And actually, let me extend this part here. It's gonna keep going, but I just wanted to kind of extend it over here. Okay, that's example 5. Now let's look at last example, example 6. What type is this one? I see that there's a square root. The points for square root is 0, 0, 1, 1, 4, 2, and 9, 3. 0, 0, 1, 1, 4, 2, and 5, 6, 7, 8, 9, 3. Okay, let's see what's happening in here. Well, the plus 3 is outside, so we know that this is a vertical translation telling us to go up 3 units. Okay, and then the interesting part is what's happening inside. Inside the square root, there's a times 2. So this is a horizontal, so I'm going to put H, horizontal compression. And horizontal is affecting the axis. So vertical dilations affect the y, horizontal dilations affect the x's. So it means it's going to affect all the x values, so I'm going to put them in parentheses. And since it's inside, remember we do the opposite. So what's the opposite of multiplying times 2? Dividing by 2. So we're basically multiplying all of these times 1/2. 1/2, 1 over 2, 1 over 2. Okay, so 0 times 1/2 is 0. 1/2 times 1 is 1/2, or 0.5. What's 1/2 times 4? What's half of 4? It's 2. And then what's half of 9? If you have $9 and you split it with a friend, then each of you get $4.50, right? So half of 9 is 4.5. Half of 9 is 4.5. Okay, so these are going to be my new points. 0, 0, 1/2, 1, 2, 2, and 4.5 and 3. Okay, so let's do that. Let's do 0, 0. Then the next one is 1/2 and 1, or 0.5 and 1. So I'm going to go half a step to the right and 1 step up. Right here. Notice I did half a step to the right and 1 step up. Then I'm going to take 2 steps to the right and 2 steps up. And then I'm going to take 4.5 steps to the right and 3 steps up. Calculate it again. 1, 2, 3, 4.5. And 1, 2, 3 steps up. Okay, and then the last thing is to move all these points up 3 units. So 1, 2, 3. 1, oh, purple. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. So that concludes our examples for today. If you have any questions, feel free to bring them up during class tomorrow. Or not tomorrow, but next class. And until then, I'll see you guys again.